Okay, so we're looking at section 5.3 in your book, and what we're starting here is we're going to start writing proofs, and this is called using theorems in proofs. A question that we're going to answer right away is, what justifications do I use in proofs? So we're going to be doing one-step congruent proofs, and the big idea here is figuring out what justification that you can give for a conclusion that you want to make. So first, let's look to see what a proof looks like. There are two different kinds. One kind is a paragraph proof, but the kind that we're going to use the most is the type of proof that's called a two-column proof. And a two-column proof, it looks sort of like a T-chart, and on one side of your T-chart is the conclusion that you want to draw, and on the other side of the T-chart is the justification that you're going to use for that particular conclusion. So most proofs start out just by setting it up exactly as you see in front of you with a conclusion, and for every conclusion you must have a justification. So what are we allowed to use as justifications in proofs? We can't say just because we know, or just because it's common sense, or just because it's what I've been told. What we have to have is something definite. And there are three things that we normally use in proofs. We can use a definition, such as the definition of a circle tells us that all the radii are congruent. Or the definition of a midpoint tells us that the midpoint is halfway between the two endpoints. We can use some different postulates. One of the ones that we'll use a lot is a corresponding angles postulate, which says that angles are congruent in corresponding places. The other thing that we'll use a lot is theorems. We have a lot of theorems, and if you remember, not too long ago I gave you a packet that had all the theorems and postulates listed in it. The only thing that it doesn't have listed in it is the definitions. Okay, so here is an example from your book, and in this example from your book, what they gave us is a triangle QRS that's congruent to a triangle TUV. The first thing on some proofs that I might want to do is I might want to draw myself a diagram, and I might want to label what I see, like this would be Q, and we'll make this one up here R, and we'll make this one over here S. And then if we're going to label the other one so it's corresponding, this one has to be T. Remember that the matching letters have to go in the same place. This one would be U, and this one would be V. Okay, so first thing I like to do is draw a diagram so I can see. The first step in every proof that you do is going to be to write down what information that you're given to start with. And the information you're given here is that triangle QRS is congruent to triangle TUV. So this is the information that you're given, and then my justification for that is that that's what they gave to me. So that's what I'm going to use for that particular one. All proofs start out with what you are given. Okay, my second step is that I'm going to use, and what I did is I looked at my two triangles that I had, and I thought about, okay, looking at these two triangles, if this triangle is congruent to this triangle, in the last section we learned that if the two triangles are congruent, Q is congruent to T, R is congruent to U, S is congruent to V, QS, this side, is congruent to TV, this side. And the thing that we're using in this one, the thing that we want to prove, I know that QR is congruent to TU. So I asked myself, what tells me that I know that QR is congruent to TU? And the thing that I know from the last section was a congruent parts of congruent figures theorem. If these two figures, which are the triangles, are congruent, then these matching sides are congruent. And notice that QR is in the same position as TU in the name of the triangle. So I'm able to make this as statement number 2, that QR is congruent to TU, and I'm using congruent parts of congruent figures for this. Now, I haven't quite finished yet because this is not the congruency symbol right here. This is the equal symbol. So I'm going to have to use something else that I'm going to be able to move from being congruent to being equal. And what I can use is something called the segment congruence theorem. And the segment congruence theorem tells me that if two segments are congruent, then they have equal measures. So that's what allows me to move from this step, that they're congruent, and notice this is saying segment QR is congruent to segment TU, and then down here this is indicating that the measure of QR is equal to the measure of TU, and this is what the segment congruence theorem allows us to state whenever we're looking at these two. So this is actually a three-step proof. The kind of proofs that we're going to be doing, they call them a one-step proof, but technically they are a two-step proof because you have to first put in your given, and then after you put in your given, then you have to put in the justification for the statement that you're making. We're going to move on after this one to doing more step proofs, but for this particular section, we're just going to do two-step proofs. I am also going to give you a copy of this table for you to keep in your notes. This table gives us some of the more common justifications used to show that different things are congruent. On the left side of the table, you're going to see that it talks about why segments are congruent, and on the right side of the table, you're going to see some common justifications why angles are congruent. You'll find that this table is very useful, but by no means does it include everything that we are going to be using. This is just kind of a beginning, so that you don't have to go to that packet and look up everything. This is just some common things that we're going to use.